There was no conscious, one day I decided that I want to become a biophysicist. That's where I realized that there is much more to biology. While it's an extremely interdisciplinary subject. We've got physics. At that point, a lot of the group there were electrical engineers who were working on, MRIs and brain signals and so on. A lot of mathematics, engineering, chemistry, everything together. I think that's when I decided that if staying in research, I want to stay at the interface of biology and physics. But I would also say that ultimately, if you're not happy doing what you've chosen, if you do not love the subject, it's very unlikely that you will perform well there. But things change extremely fast in an industry setting, and an attempt to try to connect what the management wants, what the research group wants, and what the clients want. You should make it clear that yes, they are good fits. So it's very critical to at least go through a thorough description of what that institute is about, what that department is about, who would be good collaborators. Same for job applications, same for award applications, award nominations. At so many attempts that you make to do different things, you have a lot of failures, and then you need to be successful once.
Hello and welcome to the Decoding Phase Transitions, the DPT Podcast. I'm your host Sananda Biswas, and here we decode the career phases of brilliant minds in academia and beyond. Our guest today is Professor Srirupa Chakraborty, whose journey connects beautifully physics and biophysics while spanning research experiences across industry, national laboratories, and academic institutions. Srirupa began her academic path in India, completing her bachelor's degree in physics from Presidency College, Kolkata, followed by a master's degree in physics from IIT Guwahati. She then moved to the United States for her PhD in biophysics at SUNY Buffalo, where she made the transition from physics into biological and molecular systems. After her PhD, she worked as a postdoctoral researcher at IBM Thomas J. Watson Research Center, where she gained experience in industry-style research and was exposed to patent writing. She later moved to Los Alamos National Laboratory as a CNLS postdoctoral research fellow, where her work at the interface of computation, chemistry, and biology earned major recognition, including the Wheelie Computers in Chemistry Outstanding Research Award from the American Chemical Society in 2020, recognition from the Consortia for HIV/AIDS Vaccine Development in 2019, and the NIH Early Stage Investigator Award in 2023. Today, she is an assistant professor at Northeastern University, where she leads her own research group and continues to work at the intersection of computational biophysics, molecular modeling, and biological systems. In this conversation, we talked about her transition from physics to biophysics and how that shift was not a sudden decision, but a gradual transition towards the questions that excited her. We discuss about childhood curiosity, how to choose a specialization, and what it means to move across disciplines without losing the core training. We also go deep into her experiences in the United States, the challenge of moving to a new country, her PhD research question, the difference between academic and industry approaches to research, and what it takes to write a patent. We also touched upon her postdoctoral years at Los Alamos National Laboratory, her work related to viral proteins and coronavirus research, the academic job search process in the US, and her advice to apply for professorship positions in the US. There are also very practical insights for young researchers: how to build a research group, what it takes to become a good group leader, and how to network effectively. If you're thinking about an academic career, keep a notebook nearby. This conversation is packed with practical and actionable suggestions. What stands out throughout this conversation is her clarity, honesty, and the ability to move across fields while carrying the disciplines of physics with her. Her journey reminds us that career transitions are not always about leaving one field behind. Sometimes they're about expanding the language with which we ask scientific questions. So, without further ado, here's my conversation with Professor Srirupa Chakraborty on the DPT Podcast. Welcome, Srirupa, to my podcast, Decoding Phase Transitions, the DPT Podcast. So glad to have you here today, and thank you for finding the time.
Thank you so much, Shanandadi. It's such a pleasure to finally get to talk to you after so long.
Yeah, it's true that we haven't spoken since we had left IIT Guwahati. When we did masters together, actually didn't do together. You were one batch junior, and
Absolutely.
but I find your transitions and your career journey very interesting. So you have transitioned from being a physicist to a biophysicist, and you have ventured into interdisciplinary science. When is the first time you thought that you should make a transition from physics to biophysics?
That is a very interesting point that you brought up. There was no conscious, one day I decided that I want to become a biophysicist. I think it was already there at the back of my mind. Back when I was in school, at least during our time, the biology syllabus was extensive, of course, but at the same time, it did not manage to capture all the mechanisms that are there. Biology was a lot of learning of different names and terms and so on, which I think was good at that point. Now looking back, the amount of biology I learned at that time is what I still carry with me. After school, I never had any biology course ever. But I used to love biology and I used to find physics to be the easiest of the sciences. And while I used to love biology, it's solving of physics that was most interesting to me, because to me, biology was, just a lot of facts about very interesting things about how human life works. But it's much later that I found out biology is much more than that. So both of them together was always there at the back of my mind. As you know, I did my physics first, the undergrad, and then the master's degree in India. And during the master's degree, I had an opportunity it was a summer fellowship by the Indian Academy of Sciences. And from there, I got the opportunity to choose between a number of different institutes. And one of them was an institute called the National Brain Research Center in India. That I found to be extremely interesting for two things. One is, I didn't know before that you can have an entire research institute just focused on one organ, the brain. Of course, later I found out that's very common, but to me at that point it was extremely interesting. I had just read a book by Roger Penrose about consciousness, so I think that also played a role. And the other interesting fact was, and that's kind of like a little bit of digressing here, but the building was shaped in the shape of a human brain.
Yeah.
So I really wanted to go there and see. And I think that's a great step I took. That's where I realized that there's much more to biology. It's an extremely interdisciplinary subject. We've got physics. At that point, a lot of the group there were electrical engineers who were working on, MRIs and brain signals and so on. A lot of mathematics, engineering, chemistry, everything together. I think that's when I decided that if, staying in research, I want to stay at the interface of biology and physics.
That's so wonderful to hear that you got this opportunity and that it opened up a new path for you and which you explored later. Let's go back to your childhood now. You grew up in the same state in India, and we speak basically the same native language, same mother
Yes.
tongue. Take us through that journey of your school and what are the roles of your family, parents, and your teachers, which led you to find physics as your career path just after school?
Mhm. Right. So I will say I come from a very typical Bengali family where education used to be one of the prime concerns. One of our topics of discussions over dinner was about what new things we learned. My father, used to love physics, though he was not a physicist himself. He used to love physics. He was an academician also. So his field of work was architecture and statistics, but at the same time, he was the one who would. And I remember one of my earliest memories was we were learning about buoyancy, and my father is throwing things in a tub of water, and we're learning about those things. So it's always been there at the back of every discussion that we had, not just physics, but in general, being involved with science. One anecdote here is that, like most kids, we were given essays to write that what do you want to become when you grow up? And one common answer at that time would be either doctors or several other
Astronaut.
things, astronaut. I was one of them who used to write scientist, which is you don't get much to write if you write an essay about scientists. I mean, you become a scientist. But I was really true to myself because I didn't know exactly what type of a scientist or exactly what I meant by being a scientist, but I knew I want to be a scientist. And
Mhm.
I'm very happy not many people get to say that I could become what I wrote. It may
Yeah.
not be an extremely fancy thing to be, but I could become what I wrote in my essay. So I think I'm one of those lucky few. Then, of course, there was a phase where, which is also common, at least during our time, where you give entrance exams and then medical or engineering becomes one of the top priorities. For me, somehow, what I was even by a little bit like the pressure from society would be like, you have to get into the medical field. I did like biology, but I loved physics too. But maybe some stepping back here, something else which was extremely true to the way I grew up is that I'm also one of the few people who've never taken any tuitions, which is to the audience here. I don't know who the audience is, but if you're from India, you're familiar that doing STEM tuitions was very common. It's still very common. We never did that. It's just and I something that was ingrained in us is that you teach yourself. That's the best way to learn. At that time, it was like a good excuse to, okay, then I'm done learning. I've taught myself. It's enough. Let me go out and play. And that was also common in those days, India, that a lot of time was spent just finding your cohorts and peers around you in the neighborhood and go out and go play, like, go out and, roam around and explore. That formed a big part, which I'm not sure if it's still there. I hope it is, but I think that was also an important feature that kind of molded me, exploring around us in a safe
Interrupt you,
environment.
Shrirupa, here a little bit because, as you mentioned, it is true that back then, and maybe partly it's true now also, that STEM students used to take tuition, additional tuition apart from the school, and that used to be the norm. In your case, that was not the case because the school teaching was sufficient, or you were having, as you said, you were teaching yourself. So you also got some family support to direct you through the books or through the additional help that was required, or maybe not required because school was already fulfilling its role.
It's a complex question. I think the school was sufficient for us to get what we need to learn. Schools, I don't think, was sufficient to force you towards the entrance exams, because entrance exams in India is a different ball game. You need to be extremely focused for answering some types of questions. And I must also give that to my school, which I see very positively, that our schools used to encourage a lot of extracurricular activities, which some people may argue that in 11th and 12th, again, everything the audience must understand, it's from the perspective of Indian education system. It may not hold true for every situation. At that time, we had SPICMACAY, which is, Society for Promotion of Indian Culture. We were a big part of that within our school. So there were many things that were going on. I think now, after so many years, what I can safely say, school was sufficient for us to understand the basic syllabus of science. That I think at that point, it felt like a lot of syllabus, but at least the core understanding that I brought out was sufficient. But again, it was clearly not sufficient for the entrance exam kind of preparation.
Which
From
school did you
our
go to, Shrirupa?
I went to St. Thomas Girls' School. I mean, that may also give away the fact that it's not big on entrance exams, but it is pretty big on sports and extracurriculars. By that I mean music, theater, and so on. Which later I'll maybe get a chance to go to. That also became a part of my, my
Identity.
fallback at little times. Yes, and from home it was like, if you know best, if you think you've studied enough, that's it, which I think I really appreciate. Again, hindsight is 2020. At this point, it feels like maybe I could have given more time, but overall, I think what happened for the best, because I could become the scientist, which I probably could not if I became a doctor. So
That's true.
I could fulfill what I wrote in my essay. So that's how it happened. And yeah, did I answer all the questions?
Yeah, I think you did. This
Oh,
is
sorry. I also wanted to bring something up, which is something I can, now that I encounter a lot of students, a clear distinction between some students that I feel is some who can teach themselves, some who would need, and it's okay to be either form. There's no right way in this case. But I think it may be a good idea to sometimes, given today, especially that there's a lot of information available in the internet with the advent of all the GPTs and LLMs. It's not the lack of information that holds us back. So to be able to make use of that information and critically think, it's not about how much information you can store in your brain. You don't need the storage of information in the brain as much these days because everything is at the, at the press of a button. To be able to critically think, how to critically process that information is something that everybody needs to, not just students, even us, as we keep progressing and evolving, how to kind of process the information that's given to us. I think that's a training that everybody should give a lot of time to. Self-directed critical thinking.
Yes, that's true, and it affects every parts of the life. Not as a student, also as a citizen, also as a human being, and also it affects both personal and professional spaces. This one skill can make a huge difference in one's life, and I think the schools are also, if I can say that, it can also encourage more asking questions and be open to those questions, whatever it may be, because to be critical is the center of it is asking question and asking any type of questions. So therefore, if it's in the foundation, then maybe that skill will develop naturally when they enter the professional sphere, the students from the schools. I would also want to highlight one thing here, that it feels also for you that because you were in love with both physics and biology, you went into a path not thinking too much and to what to specialize from the beginning. And whenever the opportunity opened up, you took a path, you took a decision. So for people who has the pressure to specialize early on, what advice would you give to them so that they can have their also choices open and to find their unique path in that way?
Right. No, I think that's a very relevant question. These days, because competition is even high, competition just keeps increasing, it may be that some students need to take decision early on. But I would also say that ultimately, if you're not happy doing what you've chosen, if you do not love the subject, it's very unlikely that you will perform well there. It's something that a student must envision, that is this something that I want to stay on with for the next 5 or 6 years at least, maybe even my entire career. So if you do not have strong liking for that particular domain, I think it's less likely that you'll perform well. At the same time, there are several other decision making factors. For example, a very practical factor would be what could be the possible career choices, right? If it just happens that you choose a subject, but ultimately you end up doing maybe information technology or something that you could have reached at a straighter path, then you just go ahead and do that. So I know I'm not giving you a direct answer because I think there is no one direct answer of exactly how do you choose your subject, the major of graduation. But I think it should be a combination. The first, to me, the most critical thing is, would you enjoy doing it? If there are multiple subjects, because several people may be interested in more than one subject, if there are multiple majors that one might be equally interested in, then looking into more of the practical outcomes, and what are the likely career paths going forward that might be possible. Then what are the immediate options? For example, if it could be a choice between different colleges, then but there could be several other things, right? That the college fees, the cost associated with it. Would this be something that is worth being investing in? Would it pay back ultimately? Or the location? Some people are constrained by location. So it's ultimately a combination of everything. But one of the critical players is this something that you're passionate about? So being stuck in a subject that you are definitely not passionate about can only lead to two things. One is either, a lot of failure and depression, or you end up just leaving that field. So you might as well take that decision a little earlier. But if somebody has the privilege to, sometimes people have the privilege of choice, that you can take multiple majors. Combined majors these days are becoming quite common. If that's possible, that's also a worthwhile effort to look into.
Yeah, I think it's also very dependent on the education system you are going to, which country you are going to. So, a lot of countries do not give a lot of options, but I think your relaxed approach in your life, right, choosing one path which is in front of you, which takes you to great schools and great institutes, but then if you are there, it will open up other opportunities for you. So, that relaxed approach is also important to remember. You
Sure. No,
were
but I'll also kind of, I didn't mean to say that it's very relaxing. I mean, that's like an ideal case that you just stay relaxed and it happens. It may not happen that easily.
sure, sure.
But I think it's also important to keep your goal a little dynamic, unless there are strong reasons that there is only one specific career choice that you want to fix or fixate with. It may be okay, and that happens with all of us, that you wanted to be something, and then as there can be very positive outcomes from a number of different strategies, right? Different paths. So keeping your goals, both the short term and the long term goals, a little dynamic may be helpful. But at the same time, I also feel, especially these days, that if somebody had planned that I want to do PhD, because I think that's one direction I can talk a little more from experience about. Just from your school time, you might want to mold your CV a little towards that way, trying to, whenever you get an opportunity, to do a little bit of research. These days, when I also had the opportunity to be in the PhD hiring committee of some institutes, and we see that almost everybody comes in with some research experience already. People come in with papers already. So keeping that in mind, that if your goal is to do a PhD, start early in terms of whenever you get a chance of doing some research, even if it's voluntary work. It serves two purposes. One is, of course, it bolsters your CV. Another is for you to realize, is this something that I'm enjoying? It's okay, it may sound fancy that, oh, I'm going to be a researcher, but is this something that you will enjoy? So that gives you both of these. So starting early, going towards that CV you want to build, or at least trying to, because the only thing you can do is try. At the end of the day, you should be able to tell that I did my best, and now this is what I have achieved. Another point, kind of just going back to when you said that I wanted to do biophysics and I did it. There was one constraint. At that time, there were not too many biophysics options back in India, and that was one of the biggest factors that drove me to apply outside of my country. I will say now there are several opportunities in India. The places that I applied to, not too many, but the few that I applied to, I only applied to those programs that had biophysics for people who came without any biology in their colleges,
Okay.
during their undergrad and master's preparation. So I was kind of selective in choosing what I wanted to do next.
So we'll come back to this point of you choosing and going out of India. But before that, let's go back a little bit to your journey through bachelor's and master's of physics.
Mhm.
You did your bachelor's from Presidency College, which belongs to the University of Calcutta. And then you went to IIT Guwahati, Indian Institute of Technology at Guwahati, for your master's, where we met. What were the foundational skills that you were developing during this time? And what kind of exposures you were getting that actually boosted your confidence and kind of proved to be advantageous or beneficial later in your life?
Yeah, so I think many, which again at that time probably I didn't appreciate as much now as I do looking back. So I must bring up something that used to happen during Presidency College, where there were some summer series where some very big scientists, many of them were alumni from the institute, who would come back and give lectures. And that felt very interesting, because this was the time we were studying not for the Calcutta University exams. We were learning physics from for its core purpose of to answer the questions of the universe. I think that was an important part. And that was the part where subconsciously it got ingrained that being able to not just do good science, but to communicate good science to layman or to somebody from outside the field is also very important. I think that's a skill which is very critical, which I didn't have early on. I'm still learning how to do that well enough. But seeing all of those top scientists talk so easily, and making their science sound so easy and accessible to everybody, was very important. Of course, something which is typical of the Calcutta University syllabus is going into the nitty gritty details of it, which has its positives and negatives. But I think that was the time when I went through this rigorous training of getting deep and dirty with your pen and paper, which these days doesn't happen as much, and really getting into the depths of derivations and so on. now that was the undergrad training. I must also say during the undergrad, I got exposed to a lot of other experiences, such as we used to, we spent a lot of time playing badminton. We had a very close group of friends. We are also still very close. Everybody's doing great in their different fields. So trying to balance education and an overall development has always been something that happened to me by either by design or subconsciously. And that continued on in my master's degree. But I will also say that the experience in master's degree, maybe because it's a master's program and also because of, closeness with some faculty there, which you will also be aware of, where we started to appreciate physics from a more application standpoint. It's more like, okay, now all of these derivations aside, what would be the more practical aspects of it? That was the first time I did true research, because it was a part of the master's thesis, actually getting to do experiments. That was my first. Of course, there were experimental labs before that, but doing experiments for solving one big question and adding to the domain of human knowledge in terms of research, that was my first experience. Many people get that experience earlier on. For me, it was only during masters. As I mentioned, it was also during masters that I had the opportunity to work in the Brain Research Institute. So I think all of them together ultimately, set up my profile for going forward and doing that PhD. Another thing while doing the experiments is there were two components to it, right? Actually doing the experiments, and on the other side, analysis of it. And that's when I realized I'm actually more suited for computational work than for experimental work, which that idea, that suspicion became even more ingrained during my PhD. And maybe we'll talk about that in a bit. Something that I also wanted to mention, you brought up childhood, and how childhood shapes your future in some cases, is our house had a computer from when I was 5 years old, which at that time was not too common. So maybe in a way that also shaped the fact that now I'm a computational scientist. I do biophysics, but I'm a computational biophysicist because computers have been a part of my upbringing. These days it's common. Everybody has access to computers, right? But at that time it was rare. So I was very fascinated by it. And that has remained a part of my research also.
I remember those times there were this floppy disk, and I think nobody will understand what it is. Many of the listeners will not know what
That's true.
those, and it was a privilege to have computers at home. Also, right? Not many people had it, but all these things coming together, and you apparently then decided after this exposure to the National Brain Research Center, this at Gurgaon in India, you had decided then biophysics would be your path, and that's what you want to pursue, and you wanted to move abroad. What were the preparation like, and how did you choose the State University of New York, Buffalo, for your where you have done your PhD from, to go when you moved to the US?
The preparation, I mean, at that time, I will say there was a lack of awareness on my part. Now I would advise somebody else to prepare a little more carefully in terms of listing exactly what institutes you want to get into, showing more, working more, as I was telling, towards building a stronger research profile. At that time, it was whatever was common. I think that Indian Academy of Science was a little. It just got handed to me, and I took it, but it wasn't that common at that point. These days, I think everybody has a lot of research profile to show, or at least quite a bit of research profile to show. And I think, therefore, planning accordingly. As I was telling, some people even start from their high school. So if you're interested in doing research in a good institute, those may be some things that you start working towards. The other preparation at that time was giving the GRE exam, which I think a few others in our institute was also giving. So it was like, okay, many people are preparing. Let me also go ahead and prepare and do it.
It
And I
felt
did
like
it.
festival of GR
Yes, yes. At that time, I could, and I think we all would agree that it feels like a moot process of learning those English terms. And I'm glad that these days, at least in USA, GRE is not one of the key factors anymore. Many institutes are rejecting GRE altogether. At that time, that was also a part of the preparation. And I think any preparation has its positives ultimately. So you go through that rigor. As I mentioned, I applied to only very few because I wasn't extremely sure that I will go out. I was also, in fact, interviewing within India also. And I was applying only to those institutes which had something which was you do biophysics or an interdisciplinary bio program which didn't require you to have any basic biology. It's interesting that when I did join my institute, one of the first courses was advanced biochemistry, and I had never taken any unadvanced biochemistry in my life. So, but
Yeah.
also at the same time, because it was advanced, everything was open book, more application based. So it didn't really need me to kind of remember all those. I used to be very scared of chemistry. Don't tell that to anybody because now I'm part of a chemistry department as well. But I used to find that very interesting that I'm doing advanced biochemistry with no basic biochemistry course done before. So I was looking for only those programs that was allowing that.
And then when you went to the US, were there any cultural shocks or any time that was like challenging to you because you were going from India to the US maybe for the first time, I don't know, but also it's a different new culture. So
Yeah.
in which way you face the challenges,
I
and
think
if you
every
can
yeah.
advise to somebody who want to
I
prepare themselves beforehand
Yeah,
to
yeah. That was a big change for sure. Of course, everything also felt very fascinating because everything was different and new. The landscape was different. The weather was so different. In upstate New York, there's a lot of snow. So that was like a big shock, definitely even a physical shock, really, the
yeah.
amount of snow that was there. Anything at that point, you're at such a young age that anything new is very fascinating. So I think that played a big role. Homesickness can play a role. I hear these days a lot of students even come up to me and say that I'm feeling very homesick, which is true. So I think a very strong requirement is build your tribe, your friend, your group of friends, maybe from within your research lab or outside. Doesn't have to be people from the same country, or it could be. It depends on what you want. But having a strong, a group of friends you can fall back on outside. It shouldn't just be about your work. So I think that played a big helping role for me. In terms of culture shock, nothing critical, but there were several things that was very, it took me a time to even ordering in a subway. Subway is a joint, it's a chain, which is now also common in other countries.
Yeah.
At that time, it was new. Even, going through that assembly line of ordering food was okay. It used to be difficult. And I used to just go along with my roommate who was brought up in USA and just say, I'll just have that.
Too many
um,
options.
no, yes, too many options. Something else which I still see, which I mean, there's no good or bad, which is common in USA. It's not so common in Europe, definitely not that common in India, is maybe because the landscape is vast and you don't get to see a lot of people on the road that easily. A lot of people just smile and greet each other, but not with the expectation that you'll answer, because at that time somebody would just randomly, a stranger would say, hello, how's it going? And I would take it seriously and stop to explain how it is going. But it was
Yeah.
I quickly learned the expectation here is you just nod along and ask a question in reply that how's it going and go forward. So
Yeah.
I used to take it seriously. Somebody asked me a question that
And
uh,
not
how are
wanting to
how are
know
you
the answer.
doing, and you don't actually answer
Yeah.
that, just smiling at strangers. I think it felt nice. I felt welcomed, but I think that's just a I don't think there's much meaning to it than just a practice that they have. Different countries do it differently. Other than that, it's just I think you were also asking about any advice. I think an advice could be you've come in to visit a new country, so to be open to whatever that country is kind of about, just being there as a guest and seeing how they do things, which may or may not agree with several things, several good things to learn from in the new country, several good things from your old country that gets reinforced that okay, we actually did that much better. But just taking everything as a learning experience was good. As I was telling, I have the core group. I still have the same core group of friends as my strongest friends, and used to do several things. In terms of we formed a dance group, and we used to have a lot of cultural events that we would do outside of work. So I think that worked as a very strong support system for me.
And I think the same I heard from many different people, that having a kind of community, whichever way it is formed, that is important, so that you can support each other through those initial challenges, because you go through the challenges together, face it together, and hold each other kind of through that storm if it comes, in a way, right?
Yeah, that's a good way of putting it. I agree.
We want to know a little bit of the research that you were doing during that time, and what were your PhD research question that you were addressing. If you can simply put it in a way so that we understand. I want to also understand the mindset here a little bit, because physics is a little bit about rigor, and as you said also, it was a rigorous process in the masters, right? That also in bachelors and masters, of learning the mathematics and the abstract way of thinking. But in biology there is a lot of complexity and sometimes a lot of ambiguity, like how to learn this new way of mindset. And I would guess that you have learned already during that your PhD, or giving at least having a taste of it for the first time. Tell us these differences also a little bit, your experience transitioning as a physicist to biophysicist.
Right. I think physics is a core subject that everybody can benefit from, even if you don't. Maybe I'm biased, but I think it's a topic everybody will benefit from. Everybody has anybody who's in any STEM field has applied some physics either consciously or subconsciously. At that time, though, you're right. I'm just transitioning directly from, never taking any biology courses now, focusing a lot on biology. So again, maybe one step at a time in terms of your questions. The institute that I joined, this SUNY Buffalo, they, unlike many other institutes, have something called a rotation system where you rotate in different labs, see which lab is a good fit for you, what's the science that is kind of exciting you the most, where are you feeling most at home at. That's what I did. I rotated in 3 labs. I went ahead and chose one of the labs, which was in the physics department completely. I also really appreciate the flexibility that the institute showed. That particular lab was not a part of this interdisciplinary biophysics program, but I really wanted to join that computational physics lab that works on biomolecules, and they were very open to it. However, though, there was also one more lab, which was an experimental lab. They did electrophysiology. So, passing currents through cells and seeing how electricity passes through the junctions of nerve cells. That was an experimental lab, but I really liked that topic too. So during the PhD, I was lucky enough that I could form a collaboration between both of these labs, and both the PIs later became my PhD advisors. So I have 2 PhD advisors. I learned a lot from both of them. You asked about my physics thesis topics. Just very superficially, what we were looking at was looking at something called allostery in proteins. There's several jargon terms here for those who are not aware. First of all, proteins is not just the protein shake that we have. Anything in our body, all biological functions are done by molecular machines or motors and machines and so on, which are all proteins. We were looking at some such proteins, and in an aspect of it called allostery. What allostery is long distance communication over the molecule. So, as I was telling, these are all molecular machines. So, the machine does an activity. There is a change of force somewhere or a conversion of energy somewhere. And that happens at one location of the protein, but it could be triggered by a perturbation happening at a distant point on that protein. How are these, where that effect is taking place, where that energy conversion is happening to where I did that perturbation? What's the communication between them is called allostery. So
Is it
that is what I
coming
used to
from
do.
nerve, these parts, or?
So nerve is much larger scale. A nerve is a cell where there are several proteins. So we are looking at a couple of those proteins within a cell, not just the nerve cell. At that time, though, we were looking at 2 proteins which were common in the nerve cells. But this is true for any protein in any cell. Many of them, most of them, have some allosteric effect. That means there are long distance communications that's happening across the protein. There were 2 ways we were looking at it. One of them is simply if we treat that protein as a number of ball and spring systems. So learned about ball and spring systems in physics. And now I was seeing how just treating them as simple ball and spring systems helps us understand how these, very complex, large molecules behave. I remember in our lab, we used to have a huge actual spring system of the same protein. So the same behavior of that spring, the harmonic system, in such a large scale is the same as the behavior in the angstrom scale where the protein behaves. So that was fascinating to me. And the other aspect of it would be using, so I got exposed to something called molecular dynamics simulation. So actually solving the Newton's laws of motion in trying to predict exactly how the atoms would move over the course of time. So that gave us the ability to, what I call is it's a virtual microscope. So we can look into that length scale and the angstrom length scale and in that time scale, the femtosecond time scale, which no true microscope will help you see. So that's like a extreme strength to have to be able to see exactly how these molecular machines behave over time and to be able to predict exactly how we could engineer them to do a particular task, or how does a normal protein behave versus a diseased protein behave. These are things you cannot really experimentally determine, or they're experimentally extremely resource intensive or time consuming. And that's where computers come to the rescue. Yeah. That's what I was doing. I was working on allostudy during my PhD. But of course, the focus changed. But the core idea of, again, looking at, structures and dynamics of molecules is what I continue to do even now.
I have a question regarding this. So, because you are trying to simulate the same behavior that these proteins are having in an organic environment, what are the benchmarking that you are doing to test your model against the relevant experiment?
Right. Yeah, that's a very fair question, because quite often, again, it's what, as I said, it's zooming in with the virtual microscope. The region where we are zooming in, or the length and time scale where we are zooming in, is not even relevant in an experimental perspective. So that's always one of the biggest challenges. So quite often we use, and these are for many things, these are already well calibrated. You look at actual experimental, you look at NMR studies, you look at spectroscopy studies, even energy studies like your binding energies and so on, and use those to calibrate and validate your theory predictions. Now, like any theory, the study would be this way, that if our theoretical models match the known experimental outcomes, then anything new that it predicts would be something that we would believe as a sort of a predictive. But of course, it happened to me during the PhD and even now, is that this is like a feedback loop. So we use experimental outcomes to design our models, validate them with the experiments, then use the theoretical models to predict something, test that in experiments. If it matches, that's great, but it's not as straightforward usually. It sometimes matches, many of the times it doesn't. Then use that as a feedback and improve the model and keep going in that loop if possible. So that's why I think at this point, especially these days where everything is so interdisciplinary and some of the lower hanging fruits are already kind of solved, as you go deeper into solving these problems, it's very critical that experiments and theory work hand in hand together. Different disciplines, not just biology and physics, but chemistry and other engineering disciplines all come together and solve a problem.
Yeah. It's also a very exciting phase of doing science that way, and to be able to collaborate and to be able to kind of speak the language of others. You are in the middle of it, so you are expert in that. But I was talking also about the mindset. Do you feel there is a mindset change, or because physics also teaches you the statistical errors or the statistical way of thinking, the way these models were predicting, you could also associate that easily? Or it's a kind of, it seems to me that you had a very not easy, but a smooth way of connecting your physics education to the new education that we are getting.
Yes and no, I will say. Well, yes, mainly because so I think there are a lot of unsolved problems in biology, good or bad, because unsolved because these are extremely tough problems, so not easy to solve. But at the same time, that means there are lots of questions that's still out there that physics can help solve. So I think that is extremely positive in the biophysics field. There's still so many unsolved problems, which is not often true for traditional physics as we know. So there are quite a few saturated directions. So I think that way biology or biotechnology does have a lot of questions that physics can help answer. At the same time, as you were saying, that this language can be a barrier because during our training as physicists we are trained in a certain way. It's also a language difference between experiments and theory. An example that I love to give is during my postdoc, and the same thing. So I've always worked in close communication with experimental groups. We were talking about energies, and they were saying that, okay, yes, we see energies of such and such nanometers, and I was thinking I mean, the units were kind of crashing in my brain, but
The
of course it was
wavelengths.
coming from the wavelength of the perturbation that they were doing. But I would never report an energy in nanometers. But it is actually a standard if you
Yes,
do
in that field,
an
right? Yeah.
right in SPIRs. So I think yes, being very clear about what the language means between different fields. It's a learning process. I'm still learning so many new things at the same time. So I think that's always there. I think I'm lucky that physics training has given us to critically assess everything. And that's always helped me, as I strongly even now feel everybody should have some training of physics and statistics too, very important things, so that you can, how much of a trust should you give to your observations. That just comes naturally to somebody who trains in that way.
Yeah, so nicely put. Thank you for going into the details for non-experts and explaining it in a simple words. I am pretty sure it was much harder and much difficult question that you had answered finally in your thesis, but we got a sense of your work and numerically what you were doing to model these systems. But I find your transitions very interesting because you are not transitioning from physicist to biophysicist. You are also transitioning from academia to industry and back to academia now again. So
Yes.
your next move was to do a postdoctoral research at IBM Watson Research Center. So tell us about that transition and what were you basically focusing on as your research there, and what was the whole experience like moving to the
Of course.
industry?
Yeah. So yes, at that time, this particular group in IBM, because IBM doesn't really do molecular simulations, that's not their core thing. But one group did that at that time. They had soft matter group. I still love their work, and I had, followed them in conferences, and I think that's also something important. I used to like really find them in the conference. If there's a conference called Biophysical Society, and I would like, okay, that's their presentation, I will go and talk to them. And that's how I think that connection happened. It was a great experience, I think, for a short time for a number of things. I continued to do similar things there again. Two things. One is, again, molecular simulations, and at the same time, elastic network modeling. But interesting that now I applied elastic network modeling in designing something very different from everything else I've done before, which was learning, cognitive learning platform. I was working on the cognitive science subgroup over there. So at one side, I was simulating molecules that cause Alzheimer's, proteins that are implicated in Alzheimer's, and at the same time using the same elastic network modeling to, simplify behavior of everyday objects for designing learning platforms for students that would have different learning needs. So that was a core focus that was one of the focus of that group at that point. So that also went on to show that the same learnings, we learned about harmonics in the physics in a completely different context, and we learned, then we applied them in protein, a different context, and now in designing AI platforms, but at the same time where we are using, it's a little bit of physics driven AI platform. So the same core concept of physics being applied in different areas. So that was also something that was a good outcome of that experience. Another thing is, being in a industry setting, I started seeing things that I was not aware of before. Exactly, the discussions of several other things which were not the main. I wouldn't think in a research setting those are that critical, but even in terms of what does the client want? These are not
Yeah.
things that within academia we get to discuss as much, or at least I didn't at that point. So at that time it was very client focused, and the projects would change every like so many months, that okay, our clients have changed, so the projects have changed. So these are, some people enjoy that. I didn't enjoy that as much because things were changing too fast. But I think, and now I think there's a lot of positive to that too. That can you keep up with the requirements there? And something else that I learned in terms of how career paths can quickly change. I was very happy to be there, but things change extremely fast in an industry setting, and at that time, because it wasn't the core focus of IBM actually went through an extreme rehaul where this entire division was closed. So the good thing was I was a postdoc. So the postdocs are kind of like fluid, right? So some of them left the company, some of them went into other divisions. Because I was a postdoc and had a very good manager there, I had the option that I could change. But then at that time, that the Los Alamos option came, and I thought that no, I actually prefer the academic setting where you start a research and you bring it to completion than quickly changing. I think there is excitement in both, right? Just to be able to keep up with the changing requirements and do some research at the same time is very interesting. But at the same time, at that point, at least, I prefer to take projects to completion. And as a postdoc, you're a little more open to whatever comes at that point. And I was uh, Los Alamos. There is a famous Bengali storybook at one point that I had read long back. Exactly.
Yeah.
I'm sorry?
Visheshghatak?
Vishwasghatak. Yes,
Yeah,
yes.
that has impacted also me. Narayan Shanna, the
Narayan
author
Channel,
was.
Vishwasghatak, exactly.
Yeah.
So to be just going there for the interview, and the interview was there was first a phone interview, and then there was a 2-day extensive interview of you presenting your work and talking to individuals. And just to be there, I decided, no, it's an easy choice. I'm coming here. Um,
Yeah.
I'll also say that it's in the middle of nowhere, so not all people will like that. But I prefer, empty places than cities as much. So I thoroughly enjoyed my time over there. I enjoyed both my experiences, I think. But the next postdoc was one of the happiest times of my career throughout, I would say.
Yeah. Okay, Srirupa, before going to your national lab experience at Los Alamos and before going into the details of it, I do want to go back a little bit to your industry experience at IBM. And what are the skills and what are the differences you had found at that time between academia and the industry approach?
Right. Yeah, I think that's a critical thing that people should be aware of. Again, just to clarify, I was in the IBM Watson Research. So that's a fundamentally a research place. So they do encourage a lot of fundamental research. But at the same time, the biggest difference, and to me, I had just come out of university, right? So everything was grant directed and PI directed, whereas here it was more about what the higher management is asking. So there was always a lot of or an attempt to try to connect what the management wants, what the research group wants, and what the clients want. At that time, as I mentioned before, I was in their cognitive learning group. So it was very client facing. So we had to make platforms for better learning for both, two ends of it, autistic children as well as Alzheimer's, so dementia patients. While we continue to do basic research in what causes Alzheimer's, we also had to always answer the question that what can we give immediately. The point about a postdoc is you're somewhat insulated. So it was more on the, my immediate line manager, but at the same time, it would percolate down to us that, okay, that's fine. You're doing all this fundamental research, but we should also account for our productivity in terms of what is at this point addressing the exact requirements by the client. So I think that's something very practical and that we often tend to forget in an academic setting. There's a phrase that academic timeline progresses at a very slow pace. I think that's good for good development of research, but at the same time, it is always a good opportunity if you have the opportunity to connect the dots between what would be of immediate benefit to whoever is wanting to make use of your product. So I think that was a good experience to have. That how can we try to do a bit of both. Another point was, so the measurement would not just be in an industry setting. A measurement is usually not just in terms of papers. There are many industries, many research institutes, and so was the case with IBM, where papers are encouraged. There are several other things. Because it's more product facing, patents are quite common and very highly encouraged. So I think that was also a good experience, because we don't it's not that easy to, or the filing of the patent, or to be so deeply involved with the entire process, is usually not that easily available in an academic setting, unless you work with immediate product development. Many research labs do, many engineering labs do, but not so much in physics that easily. I think that's also something that is more commonly seen in an industry setting. And the third thing, and this is something I was even discussing with some others here, is these days, especially because ultimately, even in terms of your progress or merit development and so on, it may not, and which is also true. I think I'm going back and forth here a little, but I think whenever somebody wants to change domains or change, from academia to industry or industry to academia, to be able to draw those parallels, that in some cases the measurement is in terms of papers, in some cases it could be patents, but of course you wouldn't have as many patents as you could have papers. In other cases, it could also be lines of code. For if it's computation, it's how much productive were you during a particular phase, is often, it seems these days, measured in terms of the number of lines of codes. So I found that to be an interesting metric, something that I would not have thought of otherwise. These days, it seems, I hear it's becoming even more common. So ultimately, it's about what you developed. It's also not necessary, even in academia, it's not true that it is by the quantity of the number of papers, it's also the quality. So in other words, I think if there's a student or if there is a young trainee who's thinking about these things, there can be more than one way of measuring your outcomes. So a CV, one should think of what their strengths are and kind of portray that in their CV, rather than trying to mimic what somebody else may be trying to portray.
Yeah, and to add to that, you also mentioned when we were discussing offline that to prove your productivity to your future employer, perhaps it would be a nice thing if it's a few lines of code to put it in a GitHub and put a link, or to at least show something of the output that you had invested your time.
That's a very good reminder. I think these days, especially if your work is computational, there's a lot of opportunity to show what you've done. GitHub is the one that is the most widely used. Even we would, right? If somebody would put a GitHub link in a website, we would go into it to see that what has this person been doing. And it's always, usually you get to learn a lot of very interesting things from different people's GitHub pages. There are other methods. If somebody's working with data sciences, Kaggle, and their submissions in Kaggle, or what they have participated in. There are many ways, but these are very computer or computational specific, may not work for experimental labs, but still something to keep in the mind.
Thank you for mentioning all these avenues of measuring basically your progress in research, because that's very important to keep in mind that there are different ways. It's not only a single way out. I just want to pick your brain also on the difference between the mindset in writing patent and writing paper. So if you can share some of your experience.
Right. I think they're somewhat different. The good thing in a company setting usually is a lot of the legwork for writing, because there's a lot of boilerplate stuff which we were, or as a scientist, you're not that aware of or don't care for so much. The good thing is the lawyers do help a lot with them. So it was funny to me. It was very interesting, because that was my first experience, is that we would write it in a particular way. The lawyers it would remind me of my initial days of paper writing, where my advisor would have a lot of red marks and corrections, and the lawyer would completely make it sound very different. Ultimately, the goal is this, that it should be clear that there is no other prior work that mimics this. It is not built up on any other person's prior work, unless it's your own or your company's own prior work. If it is based on other prior work, those should be specifically referenced. And if they are all, usually they should be open source and so on. And there are a lot of legalities. The good thing is, usually with the companies, you have the legal support. Therefore, filing a patent as an individual may be a very difficult task. it's always advisable because it's such a legally involving procedure to take the help of any lawyers. For writing a paper, you wouldn't need a lawyer. Or for writing a
Hopefully.
paper for most scientists, the goal is I want more and more people to use it, to freely use it as long as there is proper citation and so on, just for the advancement of science. Company cannot work that way, and that is understandable for them. The goals are somewhat different, and that's where the lawyers play a role. But I think in terms of the inventors and the scientists, they do the same thing. They focus on getting the good science out.
Thanks for mentioning the details, because many of the details someone is not aware of until they are basically ended up there.
Yeah. But I think it's best not to think about how I would do it. As again, I think it's the scientist's task would be to focus on getting the good science. If the patent is being done by a company, there are pros and cons. The pros is the lawyer will help out a whole lot, and the con is then the company is the main owner. You're just an inventor. There's that difference. Individual filing, I've never done that as an individual filing a patent. I can only imagine that it's going to be an extremely hectic task.
Yeah, of course. But once I think you go to the industry setting, even in research environment, people do start talking about patents from day one, and it seems to be overwhelming for someone who was not thinking in that terms. And a little bit of information might help, and it is also helpful to know that you are not alone in the process, because it's a teamwork, and there is also a legal team, a scientific team. They all come together to work on this. So,
and also to keep in mind that it's nothing to be that awed by. Depends on the type of science. If it's fundamental science, one wouldn't think of patents. If it's more engineering or invention, so there's discovery versus invention, right? It would neither mean here or there. It could scientific outcome, as we discussed just before, and you mentioned, too, can be in various forms. So it doesn't matter if there are no patents if somebody's in an industry.
True. But you were also mentioning how important it is to have some kind of output there to show later for your future employment that your years were productive, right?
Yes, that's
and basically to keep that in mind, if you are not publishing papers, maybe whether there is some way of putting it in a patent, or what your team is considering at that time, at least something has to be out there, right?
Yes, yes. Form. And if somebody is not in the the R&D section of industry, then the outcomes or the measurements are somewhat different. It's about, again, the amount of money that was saved by the company, or a profit made by the company, the number of people they led. There's so many different metrics. So ultimately, somebody has to the onus is on the person writing the CV, that how are you going to demonstrate your achievements.
That's correct. I do want to here go briefly into some things you mentioned research wise, which is using these cognitive platforms for Alzheimer's patients. We recently had in a podcast an MD who is a doctor, and we talked a little bit about Alzheimer's disease. But from the numerical points of view, were you using this elastic network modeling that you were talking before to modeling the protein folding or something like that, which is the cause of this kind of diseases later?
Right. No. So first of all, the first caveat is this was a work that I did only for 1 year. So that's not my main research, but still it feels nice to go back to kind of talk about it a little. There were two things I was doing. One was the more fundamental work of working with, at that time, what was thought to be the main driving factor behind Alzheimer's, which was amyloid beta. It's still known that amyloid beta is the key player, yet the mechanism over the years the understanding of how the mechanism works has changed. At that time, based on the understanding of that time, we were simulating the behavior, the folding of that particular protein, not through elastic network modeling, but through other, thermodynamics-based methods, MD simulations, and so on.
So you are basically simulating the protein, that
we were
particular
simulating
protein
the protein
itself. Okay.
That's one aspect. The patents were for the learning platforms that we designed. And those were the areas where my task was to use elastic network model to describe everyday, for example, how does a tree move, or how would a ball bounce? So everyday objects, but simulating those again, but simplifying them with the help of Green's function and elastic network model. So the two were two different
I
work.
understand.
So again, that's also, if I would have worked on any one of them, if I worked only on the Alzheimer's simulations, that resulted in a paper. There was no opportunity to having a patent. On the other hand, the other task resulted in a patent. So it was
Yeah.
just that I was given the task to work on both. Sometimes in an industry you don't have that much of a freedom to really choose what you want to do. I was given those tasks, so I did those tasks, which
Yeah.
is, I think, what I like in an academic setting, that you do have much more freedom of what you want to do.
That's really important also, right? For the autonomy that
True.
one should have also. So let's go back now to your Los Alamos experience. Um, how was the whole experience? And the focus there was a lot on the to collaborate with the experimentalists. So if someone needs to prepare themselves they are open to collaboration, but it's also a skill to talk to people
Mm,
from different backgrounds, right?
yes.
So if you can share some of your tips with our
Right.
young listeners.
Yeah, first of all, the experience in general. So I was in a division called the theory division, which is the oldest division of Los Alamos. So my immediate colleagues were all theoreticians. So that's great because I got to learn a lot from all of them. But at the same time, we had strong collaborators, and that's still continuing. Even now, much of my work is with collaborations with experiments. We had collaborators from Scripps and Duke, and also within Los Alamos that were there. Let me tell you a little bit about the problem that we were trying to solve, so that the context is a little clearer. So now I'm not working with allostery anymore or Alzheimer's. It's a new problem at this point, and we are working on viruses. So it's an interesting thing that by now, fortunately or unfortunately, all of us are familiar with how the COVID virus looks like. So you have those spikes on the surface, right? Those why it's called the corona. That's true for a lot of different viruses. Over there, we were focusing on the HIV virus. Those surface proteins are the first line of contact between the virus and the host. That means the humans. That's the protein with which they interact with the host cells. At the same time, those are the proteins, because these are the first line of contact. That's where the antibodies mainly bind. So our body triggers antibody response mainly to those proteins because they're the ones that are exposed on the surface. All vaccines usually focus on those proteins. You use those protein or a mutated form or an attenuated form of those proteins as the vaccines. However, interestingly, the viruses are also very clever. They keep coming up with new strategies to kind of overcome our immune response. One of those strategies is those proteins are literally sugar coated. They have a carbohydrate layer which acts as a physical barrier. It's called the glycan shield. Glycan is a chemical form of a sugar. So it's a shielding, a physical shielding by which those proteins get covered. Now, those proteins get covered, our antibodies cannot bind, yet it cannot be fully covered because the virus also needs to do its work, right? So it cannot fully cover itself up. The idea is the antibodies need to make their way through those coverings of sugars and find the protein and bind. Our body does a good job of doing it, but it takes time to evolve. The antibodies keep evolving. The protein, the virus, on the other hand, keeps evolving too, and therefore that glycan shield changes. Our target there was, could we predict exactly how the glycan coverage is over any particular viral protein if you know the sequence of the protein? If give us the sequence of the protein, and we can predict exactly how much the coverage of that sugar is on different sites. And that's what my work was. That's a part of the work that I continue to do even now. But that needed a lot of experimental support. We go ahead and predict something, but is it true that antibodies will now bind better in those sites? The amount of coverage can change, is different from virus to virus. HIV has some of the highest amount of coverage. Influenza has a lot of coverage. Corona had some coverage. Hantavirus these days has a little less coverage, and so on. But even within the virus, as the virus evolves, that coverage changes. The location of the coverage changes, the depth of the coverage changes, the type of sugars can change. What changes from the individual, from the human's perspective, is how fast can we develop antibodies to those specific sites that are exposed. That changes from, cohort to cohort, human to human, disease condition, and so on.
Does it
Uh,
depend on the also on the lifestyle of individuals?
Not that is known, but at the same time, a lot of things are still unknown about immune response. It wouldn't be surprising if down the line immune responses in other factors are linked with lifestyles, but antibody response so far is not.
Okay.
But I cannot give a blanket statement that it is definitely not. So far, the understanding is it is not. But that's just about antibody response. But lifestyle response does, lifestyle changes can cause autoimmune diseases, and autoimmune diseases can have strong responses to antibody behavior also.
Mm-hmm.
Hmm.
Okay.
So
Yeah.
going back to that thing, so that's what we were working on, and that did need a lot of experimental collaboration. I think that was very helpful because otherwise, every other understanding of my immunology was the minimal that I needed to know from papers, so that I could work on my. So we were at that time we were using network theory and graph theory to kind of model the topology of the glycan shield. But I would only focus on the minimal requirement of understanding of immunology from the papers. But it was with talking to virologists and immunologists that I got to know much more detail of how complex this entire system is. At the same time, it works both ways, I think, because as an experimentalist, it could be that why don't you just go ahead and simulate this or the entire virus? But for us, it's like that's a scale that we can never achieve. So there is always this disconnect that we would say, I predict, just go ahead and do this. And then we would come to know from the experimentalists that no, it's not just possible to go ahead and change that, even though the simulation suggests that that would help. So finding that sweet spot, that what is possible to be simulated, depending on what the experimentalists want. And on the other hand, what is possible to really test in experiments based on what the simulations are predicting, that overlap is often very minimal. It could even be not there, not present. Luckily, we did have some overlap. So we would have to find that overlap which is, you're looking through different lenses, and what you think of it as a Venn diagram, that overlap of what the experimentalists can see and what the theoreticians can see. We'll have to focus on that overlap and see that now that is the area that we can use for validation and for testing. So that was a big learning for me, that it's not that anything that we predict by simulations can be tested. And it was also true that everything that experimentalists want to be answered can be answered by simulations. And then I think something we discussed before is the language difference. But that is something these days is easy. If you keep meeting, at that time we used to have very frequent meetings with, every group would come together, and over the meetings initially would just keep quiet and listen to everybody, and then it started becoming clearer as to what do different people mean by different things.
Sometimes the same thing can be termed differently.
Exactly, that is true. And that can happen even within group to group, within theory, or between. So something that, as an example that I like to give, now I teach thermodynamics every alternate semester, but I teach thermodynamics in a chemical engineering class. How it is taught there is very different from how I learned thermodynamics coming from a physics class. Okay. I also know that thermodynamics is taught in mechanical engineering, in civil engineering, in chemistry. Everybody uses the same fundamental laws, but talks about it in very different or somewhat different contexts. So yes, you're right that the same things can be told or explained in so many different ways.
Which is interesting is that something as fundamental as thermodynamics could be interpreted in so many different ways, and it has actually it influence on every different field, right? We're starting from biology to physics to chemistry. I do also want to mention to our listeners that you also got some HIV/AIDS vaccine development award for your work. So could you talk about what was the work that basically led to this award?
Yeah, that is actually that was a postdoctoral research award. It's by a group called CHAVD, which is the Human Vaccine Division. Well, it was sponsored by NIH and work by Scripps and Duke and Los Alamos and so on. I would say it was actually a group effort, but I was the postdoc working on it. My work was that come up with a computational metric for quantifying the glycan shield on the surface of the protein. So that's exactly what I discussed before. And the strength of it is that same technique can be applied to not just HIV. And immediately after COVID came, we switched gears and we started transferring it to COVID, and it worked there too. After that, recently I've applied it to influenza. Now I'm taking it away from viruses to other densely sugar covered systems. In fact, we do have a recently, and that part of the work was done by my students who were all talented enough to make this into a web server. So now anybody who's listening, if they're interested, they can go to a web server and give a protein and see exactly those proteins that do have glycan coverage, to actually build those models of the glycans.
Okay, can you mention the web page for our
Ooh.
listeners?
The web server is called Glacier, Glacier. It's a toolkit for a lot of glycan and glycoscience related different aspects of it, not just the viral shield. One of the tools there is called the Glyco Shield, which is for the glycan shielding of viruses. We do have a lot of other tools that are being developed in terms of glycans. As you can see now, my research focus is wherever we have glycans. That's where I'm interested. Glycans, by the way, again is a particular type of sugar isomer.
And if I want to understand a little bit in terms of like, because you have developed the model and same model is getting used for different viruses, right? So that means that you have good understanding of the parameters that are changing from one virus to the other. What do these parameters depend on? And over the time period, can you then have a good understanding if you know the protein then to predict this? Because kind of
Yeah. Oh,
you
you hit
found out
upon
some universal functional.
yes, you hit upon what I want people, what I want the government to give me money and fund me for.
Okay.
So the thing is, just one, I think I or I represented it slightly differently. It's not a common model for that works for different viruses. It's a common method that works for different viruses. Using that same method, we can come up with a model that works for a particular virus. Because the same method works on all, it's based on these common understandings that we are focusing on certain, for this particular project, we are focusing on certain types of viruses, which are called enveloped viruses. They have a lipid or a fatty envelope within which is all the viral genetic material and other proteins and so on. On the surface of the viral envelope, the fatty envelope is also for protection. On the surface of these are these spikes. So viruses such as all the coronaviruses like SARS, MERS, and so on, influenza, HIV, Ebola, Hanta, Lassa, various devastating viruses have this kind of architecture. They all have these proteins on the surface. They are either, they're repeats of either 3 or 4 repeats of the same protein that are stuck together and are sticking out like these spikes. And they have some sugars present on them. The sugars are present on specific signature sequences. I don't know how familiar the audience would be about protein sequence, but protein sequence is like a set of alphabets of 20 letters. And if it follows a particular pattern, you can predict where the viral type of glycans will be present. Not all glycans can be predicted, but a particular type, the ones that are most common in viruses, can be predicted as to where they are. The type of glycan cannot be predicted, unfortunately. They are taken from experimental data, usually mass spectrometry. Or if we don't have that data, our tool will just go by what's the most commonly occurring glycan types, what is most known by literature, and then model by that. But if somebody has that detail of exactly what type of sugar is present in any particular location, that could be modeled as well. Then the basic driving factor is just physical chemistry. You've got a number of atoms. Some atoms are charged. All of them interact by Lennard-Jones potentials. Some of them are bonded. There are dihedral constraints and so on. So this entire field is actually extremely well developed for a long, long time, called the force field. That's driving all the interactions of atoms. It's just based on that, and based on the idea that we can use Monte Carlo sampling, a random sampling, by giving some stereochemical constraints and temperature constraints and so on, as to how it would behave over time and what would be the different possible orientations the glycans can take. So it's driven by fundamental physics, statistical mechanics, as well as stereochemistry. So it's a combination of all of these. Again, all of these are extremely well developed theory. None of them developed by me. These are well established all over. We just applied it towards the development of the glycan shield modeling. Sugar simulations were not that well developed. This field is progressing fast. We did contribute a little bit to it, but several other groups everywhere are contributing a whole lot to it too. So it's an upcoming field. That's
Yeah. Yeah. And very interesting also that you could, the way you described that your model or your method can basically predict.
Right. Even we were surprised that even with such simple explanations of behaviors of atoms, it does do a pretty good job of matching very well with experimental observations. The thing is, these glycans are very difficult to study experimentally. They're extremely dynamic. As I said, there are different glycans at different sites. So that's why there is this need to do it computationally. But whatever experimental observations we do have, they seem to, at least overall, match quite well with the computational models.
Thank you. Let's talk about your transition next. So, you are an assistant professor now at Northeastern University. Now, let's talk about the job search a little bit. How was your experience like, and when did you start, and how important is the timing after postdoc, and how many years of postdoc experience do you need to have? If you can talk about the timelines a little bit.
Yeah, so at that time, while I hadn't given timing much thought because I did one postdoc, then I did another postdoc, and then I decided. Then I decided that it's time to apply. And how that happened is because of a thing that Lanel does very well, which is, I think, something that I really appreciate, is there all postdocs are basically limited to 3 years. Somehow I happened to be there in 4 years because there was a talk of conversion and so on. But that aside, my understanding much later was that, and that happened much later when I joined the current position, and now I'm also in the search committees, that it's usually best to not keep doing postdoc for too long, because it's a fine balance. Because something that the search committees look for is trying to be able to show your independence. If you keep doing postdoc for too long, then the question comes up that, can this person really do research independently? I don't think that's a fair way of evaluation, but I cannot also see a better way of evaluation, that you have to have some metric to show that you work independently. Either show a lot of a corresponding author writing. Sometimes that's not possible in most cases because you're working in a group, so one postdoc cannot suddenly be a corresponding author. So usually limiting our postdoc to only a few years, changing a few, getting experiences from different places are important. But anyway, at that time when I started to apply, it was peak COVID. So the first year, that was in 2020 when I applied, I interviewed at two places, and suddenly both those places had hiring freeze and stopped everything, and they couldn't have the in-person interview and anything. So everything stopped. But I think that worked out well because I had the practice, right? So I had the practice to get the entire package ready. And then in 2021, I went ahead and applied again all over. So in USA, it happens in a particular format. Every continent does it differently. In North America, especially in USA, how it happens is there's a particular time in October and November. All the applications come out. You send your package in. There has to be a teaching statement, a research statement, and a outreach, or what used to be called the diversity statement, that used to be there. In December to January, it would be a phone interview. And then January to March, depending on which institute, you would have in-person interviews that would go on for 2 days. So you would have a research talk. You would have something called a chalk talk, which as a postdoc, unfortunately, nobody is familiar with. This is where you talk about what you want to do. And maybe I'll talk about the chalk talk in a bit. And then you have interactions with a lot of different scientists who are there, students even, and everybody. The biggest challenge is somebody has to keep it in mind that this is a numbers game. You'll have to apply to a lot of different places and you'll get calls or not. I read somewhere before that it was I think a letter or some discussion in Nature, in one of the Nature publications, that at that time the trend was you'll have to apply to 50 different places to get one call back in higher education. I took that to heart and I applied to 48 different places. I would have applied to more than 50 if there were openings. I applied to as many as I could in terms of openings that were there. I got called back from 5 places. I will also say at that time the percentage may have been good because of the fact that everybody was going through a pandemic and I was working with viruses. So that may have worked to my benefit. So ultimately what I mean to say is you should keep applying to as many places as you are finding positions open, and of course to places where you think you may end up going. It's not that if it's geographically a place where you're not going to go, I would advise against applying, because you're then holding up the position for somebody else. Because quite often
it's not a good idea also to it's not also a good recommendation if the colleagues speak among themselves. So
exactly,
if you're not
right. So the ones that you would genuinely, usually it is best if you, I did have the freedom to have geographical mobility within USA. So I chose to apply to a lot of different states, only those places where I knew I would be able to go if needed. Take the interview as a two-way process, and that's true for not just academic interview, for industrial interview too. This is where you'll spend time for the next several years. If you're planning to set up an academic lab or a research lab, this is where you want to see your research lab thriving. So of course, while you attend the interview to kind of portray your best self, advertise for yourself, at the same time take all the opportunity to see, is this a good place where you envision that you can have the research work that you want to do? Maybe there are good collaborative opportunities there. Maybe there are good experimental resources that you need to use, or computational resources that you need to use. Maybe it's in an environment where lots of other industries in the area, which would be good collaborative sources or funding sources and so on. So several things can come together or not. That would help you decide that, yes, this is also a good place for you to work in. So, and I think that kind of takes the pressure off of the interview that, oh my God, they're going to judge me, because you are also kind of judging them.
This mindset is very important also, I feel, to check also for whether they are also fit for you or not. Because a lot of time we think that, oh, we need a position and that is so much important. We forget to also check the list for whether they are fulfilling our requirements or as well or not. In academia, you do of course have a feeling when you are applying that what kind of facilities they do have at that place and what are the kinds of colleagues I would end up having. So you do check also at that time. I would also like to add another point that I also saw this from and maybe a nature, maybe other. This was advice for applying that you have to be in the job market for 3 years to crack it at the end. That means also, which I think also very important, and not many people would have thought this true. So basically, that means once you are end of your first year of your first postdoc, you have to just keep applying. And
I think it's never too early to start looking. Always networking at conferences. Some of these conferences, things that I wish I knew at that time and now I know I would want to share, is some conferences actually have future faculty seminars. So you sign up for it. Of course, it's a selective process, but if you do, many of the universities that are going to hire that year just come over. I know AICHE, the American Institute of Chemical Engineers, have it. AAAS has workshops for future faculty and so on. So these are all things that everybody should be looking into. There are lots of fundings, which is, so I'm telling all of these kind of from the US perspective. I know different continents work in a slightly different way. If you could bring in your own funding, that's always a plus. I did not, but there are many opportunities where you do. So being aware of those things are always a plus. So not just applying to the jobs if you're looking for academic job or starting a research PI position, looking for all the other things that might help you get that position is also very helpful.
You mentioned that you applied to 48 places. That means also modification of your application package for 48 times.
That's actually very important. Whereas what I did in the past, the essays for those remain the same. Why that particular position is suited for me is, and that is why even though there may be more positions open, you cannot apply to all, because you know that not all of them would be pertaining to what you do. In some years, it may be less than 48. In some years, there may be more than 48 and so on. As I mentioned, because hiring was frozen for 2021, I think 2022, we're doing hiring for the 2 years worth of positions that could have been available. I've heard people who applied to 100 places. I've heard of people who applied to 10 and still got a position. So it's all ultimately a numbers game. So you just try as many as you can, as many as you think are good fits. But because they are good fits, you should make it clear that yes, they are good fits. So it's very critical to at least go through a thorough description of what that institute is about, what that department is about, who would be good collaborators, how your work is complementary to what everybody else is doing. Yours will not be an isolated island of research. At the same time, it will not do the exact same thing that everybody else is doing. What would be the resources that you could make use of over there? And in other words, why would you be a success in that institute.
Yeah. Yeah, and you also talk about this chalk talk. So in some places also they require you to teach a class, actual class, and some cases I think where these are replaced by chalk talks. So
Yeah.
tell the experience of your chalk talks and how
Right.
does it happen?
Yeah. Again, more from the US perspective. So, US has different kinds of institutes. Some universities are teaching focused, some are research focused. I had applied mostly, actually all, only to the research focused ones. But because they are universities, teaching is also a part of it. So, I did not need live teaching demonstrations in any of these. Also because of the fact that because my postdoc was at Los Alamos, and then before that at IBM, I had never had the opportunity to teach before, so I don't think my CV was very well suited to. I did not have a good portfolio of teaching to demonstrate anyway. At the same time, it's always even for the institutes where teaching, it's not teaching focused, where it's research focused, yet you're required to teach to some extent. It is always beneficial to show something in your CV. And for this, I will, for everything, in fact, at that time, I will really, give kudos to my mentors at Los Alamos. They were the ones who first pushed that, yes, you should go for, you are suited for academic positions, so you should go for it. They were the ones who were, of course, championing my cause. Writing recommendation letters are very
Yes.
important in academia.
That is
Maybe
are
we can
also
talk about
important.
that too.
Yeah, yeah.
Yes. And they were some of the ones who suggested that because I didn't have teaching experiences, I could supplement this by some other outreach activities. And the area where Los Alamos is located used to have a lot of, there used to be something called a math festival for undergrad students. There used to be science fairs, coding hubs and all that. So I used to volunteer for them. It worked both ways. One, it would give me an idea that how do I enjoy teaching and interacting with students. And on the other hand, it would give me something to put in my CV, right?
Mm-hmm.
I think that those were the ones that really helped. And I really recommend everybody to find some opportunity to have some outreach. Those who are interested in trying to explore academic life, to have that opportunity. So anyway, going back to the interview process, one of the institutes needed me to send a short 20-minute video of a teaching demonstration. It wasn't live teaching. But I think that was the trend set by COVID, that you may also have to teach online.
Yeah.
So I think at that time the pressure was a little lesser. And I did make use of some of the science. I was talking about the science fair things that I did. So some of those experiments or demonstrations, I made use of that. That was the only teaching experience I had to go through. Chalk Talk is somewhat different. Chalk Talk is about, it's like having a live demonstration. It's like a proposal defense, but now you're defending it to the proposal committee, that what is the research that you want to do, what would be your specific aims, and how can you defend these to a group of people who are out there to see that, okay, but what could be the drawbacks? So why do you think this will work? What do you think would be the drawbacks? You're saying you're going to do it this way, but what made you think that this will work? So it's a detailed, in-depth dissection and criticism of the first few proposals that you will send out. So that gives the committee an idea of, have you thought about what new research you're going to do? Are those meaningful research? Are they something that's tractable within a particular amount of time? It's not that you would need unlimited resources and unlimited time and only then you can do that research. It's like within limited time and resources, what would you have done? Yeah. What would your first few proposals be? So getting those slides ready or those thoughts ready, that what would be the first few proposals I'll write out? What would be the institutes, the granting bodies that you would target? So first talking about the research, the different specific aims, their limitations, their backup plans, alternatives and so on. And expect to get into a lot of detail because there will be at least somebody who, or a few of them, who know a lot about what you're doing if it's a similar department, and will really, get you for telling different things. It's also a good opportunity to show that how much you've researched that institute, that you know who your prospective collaborators could be, what would be the resources that would be beneficial to you, why that institute is good for you. There's always a discussion about, now, when you start, how do you envision your first few years of lab? How many PhD students would you need to start your work with? How many postdocs would you need, if any? So what would you need to be successful in that institute? Because they are gauging that, is this something that we can give you?
Yeah.
Because we want you to be successful, but is this something that you can do while you're here? And it's also good for you to let them know, because it will be a realistic discussion that I do need, very true to myself, this is what I need. And I think your institute can provide me. And that's why I've applied it here. And that's why I've come here to see, I kind of have this discussion. And at the same time, there's always a short discussion about what you would want to teach. Is there any new course that you would like to develop? What's your past teaching experience? What is your mentorship style? Mentorship style for undergraduate students, mentorship style for graduate students, mentorship style for other peers and colleagues such as postdocs and so on. So overall, the idea there is to portray to others that you have thought through this entire process of establishing a lab.
That's so well said, and thanks for going into the details, because you have to be prepared every possible way so that you can start the job next day, basically. Because
Exactly,
if you have
that's true.
thought every aspect of that job, then it will be easy for you, and
Right.
they are also checking whether you are ready.
Yes. Oh, and I must also, something that I forgot to mention is, among the 5 that I got called, one of them was another national lab. And so there wasn't any discussion about teaching at all, but they did have a chalk talk too. So there it was just about research and the resources. So and in most research-based institutes, the expectation ultimately is that you would have about 60 to 70% research expectation, about 20% of teaching expectation, and 10 to 20% of service expectation. Service means administrative roles within the institute as well as outside within the scientific society.
Outreach also, yeah.
Outreach and leadership roles. For example, I'm very strongly engaged with the Biophysical Society, then with the American Institute of Chemical Engineers. These are all expected and a part of my job description, which works well for me too, because it kind of gets my name out there. But this is a part of your job description, that the division of labor has to be either 60-20-20 or 70-20-10. Research, teaching, and service. For the more teaching focused institute, the percentages might be different.
Yeah, that's true. And also talk about your experience of building a research group, and what is the research group focusing on right now?
I see. Yes. My research work is still computational. We are a computational group. Our lab is called the Symbiosis Lab. So it's a portmanteau of the word simulations of biomolecular systems. As the name suggests, we do a lot of computational simulations. And the biomolecule part, the biomolecule that we are interested in, are glycans and glycoproteins, the same, the sugar conundrum that I mentioned before, but not just on viruses. Viruses do form like half the work that we do. The other half is other systems that are highly densely glycosylated. A big area of that is hydrogel. So mucus, mucus, simple terms, phlegm, but the mucosal layer inside is extremely important. It has a lot of very unique biomaterial properties. So can we take inspiration from these biomaterial properties to actually design biomaterials with the help of glycans and peptides? So that forms the other wing of my research. But ultimately, the common thread here is better simulation and better theoretical modeling of systems that do have glycans. Now, about 60 to 70% of all proteins in humans have some degree of glycans. So you do need those modeling methods. It's not just my lab. There are several other groups where carbohydrate research is becoming more and more intense these days. I'm just doing a small bit of it. Now, setting up of the lab, I think it was a very good experience. I'm very lucky that my starting group of students and colleagues within my lab, all of them are extremely talented, and they are the ones who are making my lab what it is now. Again, thanks to my institute, I could reach out to the students even before I joined, the new group of students who would be coming in. So I did get one PhD student and one master's student even before I joined. We started discussing. So that student, the first PhD student, is set to graduate this summer. So I'm extremely excited. He's done very good work. And then after that, so right now I have 6 PhD students and 2 postdocs, and a number of undergraduate students who've been there, and many of them are graduating this year because I'm also in my 4th year now. So they're also graduating. The lab setup, because it's a computational lab, it was, I think, less intense than how an experimental lab would be set up. But we did have a lot of, getting on our hands and knees and even putting up all the entire setup of that room within our lab, the work desks. And then we have got a lot of GPU clusters, high performance computing clusters. So getting them ready and running. They're still getting ready and running because I just bought them last year. So it's all been a very interesting process. So I think for as a student, different labs have different things to learn from. So if you join an already very well established lab, you have other kinds of experiences. If you join a new lab that's just getting established and you're one of the founding members, I think that has a very interesting learning experience too, because you're thoroughly engaged with the establishment of the lab. So it's not that there are well established protocols, you just copy somebody else's protocol and repeat the same steps. Everybody works on completely new projects. In well established labs, you can always have a senior PhD student and a junior PhD student, and you're just taking along the work done by somebody else. In my lab, and that's true for all new labs, is everybody's working on completely new projects. So it's their baby that they are kind of
That's
developing.
nice to put, yeah.
And I'm lucky that my group is extremely, first of all, they're very collegial. They have this group dynamics is very strong, and I learn a lot from them, and they're all very talented. So that way I'm very lucky.
Talking about being a group leader, what what is your role you see that, or you think that a good mentor should have to lead a group like this with postdocs and PhD students?
This is something I'm still learning. What should a good mentor have? And I think I'm keeping on learning this over time. But some of the things that I learned from my mentors are things that I'm trying to emulate. I said, as I mentioned before, I had two PhD mentors. I from one mentor I learned how to look into the detail of everything, and from another mentor I learned about the big picture, that what's the big scientific question, and think in the broad context. From the industrial setting, I learned about collaboration and the client engagement and immediate turnaround of stuff. From Los Alamos, I learned several things from all my mentors, how to be great scientists. From all my mentors, I learned how to be great scientists. But at the same time, now these are the things I'm learning to kind of emulate. I hope I'm doing an okay job. But
Pretty sure.
my understanding after these first 4 years is that there's no one mentorship strategy that would work for every student. Different students thrive under different students, and trainees work under different thrive under different mentorship styles. Some like a lot of structure that you have to give well defined. They prefer to have well defined structure. Some prefer to be left alone and they'll run with their project. And there are good outcomes out of all of these, and some people are in between. And I think as a mentor, the challenge is to find out what works best for a particular student. That's something that I'm still trying to learn. I hope I can give you better insights in a few more years.
Yeah,
I
thank you.
also
But
feel
it's
like
time
I learn a
consuming,
lot.
yeah? Because you have to spend time with each of them to understand their style and what
Exactly.
works best working environment for them. So it's a time investment. I can totally imagine that after 4 years, when your first PhD students is going to get graduated, so you are going to get a lot of experience in the coming years.
I'm hoping so. And the biggest that vindication is when the same students for now they say that, oh, I think next we should do this. No, I think we should also work on this particular paper. And it's like, okay, now they are mentoring me and keeping me back in focus on what we should work on and coming up with new solutions, new strategies. So these days, I think the roles are already starting to kind of change. They're the ones that are kind of guiding. I'm just being the manager, bringing all of them together, and they're the ones that are leading their projects. So
such a beautiful leadership. Only under such impactful leadership the students can have this, because I think also, because if you cannot impart that confidence to your PhD students, they cannot be open to giving suggestions. And if you always have critically assessed their whether good or bad openly, then only they will be, in a later stage of their life, be open to voice their opinion at any room, whether that is in their next postdoc or in bigger groups when they go.
That's true. Now, whatever I said is, of course, how I see myself. I think a better, fairer judgment would be if you ask my students.
Sure. That is true. So
I'll also say that our institute does a good job of having mentorship mentorship given to us. So, for example, even all the junior faculty, all the tenure track faculties have got mentors from the department who are more established professors. And if we have any questions, or if we think that, okay, how should we deal with such a situation, we always know whom to go to. And there are similarly teaching mentors who are wonderful teachers to ask about how should we do this, how can we handle teaching. In the first year of teaching, as I said, we came with almost very little university teaching experience. We are given in the first semester the task of teaching jointly with another well-established, who's my teaching mentor, with another well-established teacher. So you teach and learn at this. So we used to divide the classes, but I used to firsthand see how a good teacher teaches. So that, I think, really strongly shaped the way I teach. Again, another mentorship that I should mention here. So I think it's ultimately learning from a lot of other mentors and then trying to see what best I can do.
Symbiosis, right?
This is
also.
I love that.
For listeners, if they want to join your research group or be interested in what Northeastern University is offering in terms of PhD and postdoc, what is the best place for them to go and search?
Yeah, LinkedIn is good. Usually an email is better. And I think that's also something that, okay, maybe since there are several parts to the questions, the first things first, for PhD students, all hiring is through the PhD hiring process of the department. So it is not usually individual hiring. It is through the department. So the department has a search committee for students, for incoming graduate students. Of course, we indicate that, okay, I'm looking out to take a student this year. So they keep in mind that who are the different labs who are taking in students. And why is it done this way? Because usually the students come in, then they rotate in 3 different labs. So you're not initially assigned. There are ways. Sometimes you may prefer that there's already a conversation and there was a good match, but those are rare. But usually you go through this rotation experience. And I'm a strong proponent of this rotation because you get to spend time and you get to see that is this a lab that you'll be happy being in, choosing between whether you want to do experiments all your time in the PhD or theory or a mix of both. So those are very critical choices. So there is an application portal that again opens in October. It has to have a personal statement. It has to answer some questions, as in what is your research experience so far. It asks several, very insightful questions about your professional development. And then, of course, there is recommendation letters. These days, GRE, the scores are taken if provided they are not really looked into with that detail. Transcripts are important. So it's a holistic approach of different aspects altogether. Your past research experience as an undergrad, because these days almost everybody comes in with some research experience. So it does become critical. PhD is usually, at least in my lab, it's always through that pipeline. Postdoc is more just, when there's a position open. Right now, though, as I said, I don't actually have any open positions either in PhD or in postdoc, but many other labs do in Northeastern. They come out in the career page of Northeastern. So Northeastern has a career site. Some other opportunity, not just Northeastern, anywhere else. I think if somebody's is interested in the biophysics field, the Biophysical Society website has a lot of positions open. Then the higher ed job pages, those were the ones that were most helpful to me. Even Google Jobs. I think Google was doing a good job of pulling all the job positions from everywhere. Now, these are the known ways, right? Now, if somebody wants to have an interpersonal connection and then use that approach, of course, a face-to-face meeting in a conference is very helpful. That you say, hey, by the way, I liked your talk. I work on similar things. My presentation is on such and such time, or my poster is on such and such time. Why don't you stop by? Maybe usually what helps is have a card with your name on it so that somebody remembers, or even if that's not there, after an interaction, sending an email. Those are helpful because if somebody is seriously looking for the next cohort in their lab, in a conference, you can go to their poster and really see what they're doing. If it is through email, I will also mention something that unfortunately there will be, even for a new lab like me, where I'm almost a nobody at this point, there are several tens of emails per day. For an even more well-established lab, I can only imagine how many they get. So something has to make your email stand out. So like we were talking about the CV before, having a general email of, okay, because something that always stands out to me is that some people you can clearly see is a made up the same repeat of an email, because it'll say that I'm very interested in the experimental work of catalysis that you do, and I know that I don't do experimental work of catalysis.
Yeah.
And same here, because applications come in from other parts of the world. So it's okay if you don't use the same ways of, calling somebody, because different cultures have different ways. So that's all okay. But I think it's safer to stay away from sir and madam, because there's always a scope of making an error. Uh,
At least you haven't seen the web page, right? That's like
especially as a postdoc, if you're just doing a lot of cold emails to hundreds, then it becomes clear. Whereas it doesn't have to be long emails. A short email of why you're interested, it comes up. So, but at the same time, even if somebody is sending very good emails and they're not hearing back, it may also likely be that that person is not right now looking for a position. So it's okay not to give up, give up hope or give up attempting. But if somebody does not hear back after sending several emails, I think it's a good time to rethink how somebody's written the CV, how somebody's written the cover letter. Because if it has not worked, there's a high chance that it'll not work for the next 10 emails either. So there's no harm in completely, moving things around and writing it afresh or changing it afresh. But by cold emails, the chances are always lesser. Applying to those labs that are having positions open through websites or through job listings, they are the better chances. Targeting new labs is always higher, because a lab that has started this year will immediately look for postdocs and PhD students. So again, while there's no one way of doing it, what is important is somebody gives full attention and genuine and shows genuine interest, because it's also about that person really, again, being successful in that lab. So if it's a completely different research that they're not interested in, there's no point in applying.
There is no point.
Yeah.
That's true. I do like to go to our fun section, which is we talk about some of the interests of yours,
Sure.
personal interests. But before that, I have a question, because you also mentioned that when you went to the industry, you were actually doing a good networking because you were following the IBM people on conferences of biophysical societies. Did you have any particular networking strategy? Because there are different personalities, every person is different, but you cannot survive alone in this world, and it's very important to talk to other people and have networking skills. So if you can talk to the young listeners, how and what strategies should they follow for networking in, of course, conferences, but also otherwise, if you have any suggestions.
Yeah, other than conferences, okay, let's get the easier one out of the way. Conferences are the relatively easier one, especially if you are presenting, because if you're presenting, that's a good platform to start that conversation. Other than that, too, even in a conference, if there are certain groups that you're really interested in, I always, and I do that even now, because I'm always looking for collaborators or other people whose work I'm interested in, is I go through in detail the program of the conference to see who else is talking on similar things. So there's no harm in shooting an email saying that Professor so and so, yeah, I'm attending this conference. I see you're doing it too, and your work is on this. I will be presenting on such and such time. It will be lovely if you could just if you could stop by for a minute for a conversation. You'll not hear back from many of them, but from some of them you might, right? Similarly, a good place to start would be around the city you are. There may be other institutes that are there, or in your institute, other professors who are there, other departments who are there. So whenever you have a paper out, something that I recommend my students do is, if you've met somebody earlier in a conference, or somebody whose work you have followed or whose work you've closely cited and your work is building up on it, why don't you share your paper with that group? It doesn't have to be in the lookout for a job. You're in your second year on PhD. To send out saying that I've built upon your work and we are doing this, we would appreciate any thoughts on this. So you're already kind of getting into their radar, and you're doing it in a simple way of email. It's less scary, even if they don't reply. It's okay, but everybody loves their work to be cited. So I think if somebody reaches out to me that, hey, I've built upon your work, and your work inspired me to do this other work, I would show some interest. And it just keeps the name in the radar that email is now not going to be a spam the next time. So just getting into the visibility of some people, doing outreach activities, I think, again, so there are often outreach activities by different institutes to the common people. those are good ways to overcome your fear for talking. I think research is a field where you have to talk a lot, whether you enjoy it or not. After a point, you just get numb to the fact that whether you enjoy it or not is not a factor anymore. You just do it. So, getting more and more opportunities to practice giving a talk, I think, is very important. It
Yeah.
could be within your group because, and in terms of networking, having and this is something that my one of my PhD advisors advised me, be ready to talk about your research one in a 3-minute setting as if as if you're explaining it to 10th,
Somebody in an
10th
elevator.
grade student, a 3-minute pitch for somebody you are explaining who is core to your topic, having a presentation ready which is about 10 to 20 minutes long, and having a presentation ready that's 1 hour long. So it should be ready. But those 3-minute pitches are extremely important because if you're walking with somebody,
Yeah.
maybe even on the road, maybe in a different institute that you're visiting, and in 2 minutes you have to impress that person about your work. So having a 2-minute, because a question that can sometimes get us stumbling a little is, okay, tell me about yourself.
Yeah.
Now, where do I begin? So
Yeah.
having that answer ready of tell me about yourself, I think is very important. LinkedIn and social media these days are okay opportunities. I think quite often these are just cold messages that are ignored, but sometimes they are taken up. I still think the biggest opportunities would be either conferences or local venues where if there's any outreach activity by any other institute, by any other industry in your area, or even maybe a little outside your area, taking that investment to actually visit some other sites on your own behest, not necessarily paid by somebody else,
Yeah.
may be worthwhile sometimes.
Great list, actually, different ways to do networking. I also want to add on to the fact that you can also maybe towards the end of your PhD or even beginning of your PhD, if you have a paper published which is of interest to some groups, as you said, emailing, but also requesting for a talk. It doesn't hurt.
Sure, yeah, that's a
You
great
just
idea.
could offer that I can come and give a talk or present my work in a group talk or whatever setting you have. And I'm
Very
in the
good.
area, by the way, from this to this dates.
Mhm.
And it might work sometimes because
Right,
people
right.
do like to invite people who have recently worked on the same topics and get their opinion, even as PhD students,
Mhm.
right?
No, I think that's a very important point that I missed. That just volunteering to
Yeah.
disseminate your knowledge to others, it gives you first of all like a mock interview practice, and at the same time, those other groups start. Even if they're not hiring, if it's a
Yeah.
person who's working on the same field, now they'll be aware of your work, and they may recommend you to. And next time you see another position somewhere else, and there is a connection through this person, you could say, "I'm reaching out. I'm applying for that. Would you mind putting in a good word for me?"
And also, you will have a fruitful discussion afterwards because they are
Exactly.
also experts in the similar field. So
That will
new
always be
avenues can
beneficial to
open
your
up for
work.
collaborations, even. So who
Perfect. Yeah.
knows,
Yeah. Yeah.
right?
No,
Uh,
that's I think one very important strategy towards the end of the, or
yeah.
yeah, like by the time
Or
you have something worth presenting.
yes,
Yeah.
exactly. Thank you, Srirupa, for taking the time and answering all these questions.
And thank
Let's
you so
go
much.
to a little bit of fun areas.
I
So,
love that.
some fun trivia about you. Do you have hobbies?
Yes, I do. Nowadays, the time is a little less for doing those hobbies, but in general, my hobbies, it's a lot of reading, reading things outside of my work. It used to be a lot of fiction before, now a little bit more of nonfiction, geopolitics, geography, and so on. That's, just a casual thing by the side. As I was telling during my PhD, I had a great group of friends with whom we started dancing and Indian cultural arts, dance, theater. I think that really shaped a lot of the things, a lot of how things turned out because, to help you think outside the box, all of them were graduate students at that time, but from a variety of different departments. So even to be able to talk about your research to somebody outside your department, if you have to complain. At the same time, to create something which is meaningful, but not necessarily just your research. At that time, we were doing dance and we used to call it creating something. To us, it was a big deal. So I used to really enjoy that. I continued that in some of the other places, but not so much anymore. But I'm hoping I can get back to it again now that my toddler is growing up a little. Okay, another hobby that I share with my partner, my husband, is we love to travel and we love to hike and camp. So hiking and camping is something that we love to do. By the way, that's a annual thing that I do with my students too, that once a
That's
year we
very
go
nice.
out for camping. Uh,
How long it is?
we just do it. So far, we've always done it for one night. We just go
Okay.
camp for one night.
And
But
there
then
is
I'm
no
doing it.
talk involved as in Europe, right?
I
There
didn't
is
get
no talks involved in the hiking.
no camping talks.
Because no, because we have these kind of annual group retreats.
Yeah.
They are called group retreats in many places actually in Germany. And then there is a whole day of hiking, and then end of the day, like let's say starting from 5-6 o'clock, then up to 10-11 o'clock, they will start talking, giving presentation, and the
Yeah.
next day will be something.
We do that is not within my group. We do have some conferences that are very focus groups of conferences that
Yes.
do work, not so much of hiking, I think, but at least some outdoor activities. This one is just camping, but other than that, in terms of just more personally away from the lab, we do hike and camp quite a bit. Kind of trivia about me is just this year we finished visiting all the 50 states of USA.
Wow. So all the
At least
national
spending
parks
one,
also?
not all the, because it's too many national parks we are realizing, but quite a few of them. There are 63 national parks, and we counted we've done about 40 of them.
Wow. That's
But,
amazing. That's
but
truly incredible.
right, not all national parks were places where we've spent a night, but at least been through it. The 50 states were done as like we've spent at least one night in each of those
Mm.
states. So it may have come from the fact that we did have this two body problem for quite some time. We were in different states, so quite often we would just, instead of flying to each other's place, we would just fly to a third place and
Yeah.
visit there. One advantage of computational work is, and again, the flexibility that many of my mentors gave is, after it was established that I'm being able to do what I'm doing and I've learned the things and now I just need to do, we would often just take a camper van and keep doing work from the camper van
That's
and maybe
nice.
spend a month in different places. Again, for the
Quite
last 2 years, this
exciting.
has kind of stopped or at least reduced to a large extent, but hoping to bring it back up.
It sounds amazing. Amazing. Keep it up, and hopefully this will be a lot more enjoyable with your toddler when
See how that goes.
nature
We did
and
start taking him out for a couple of long, camper van, several days in camper van. He's done two of those, but
wow.
yeah, let's see how
Yeah,
it
that's
goes.
so nice to hear. Yeah, you mentioned about books. Do you want to mention one or two books which had impacted your life deeply?
Oh, it's a tough thing. I mean, there's so many
Yeah,
books,
I can
right? Books
imagine.
that have,
Yeah, whatever is coming to your mind right now.
oh, I won't go into the geopolitical ones because those are so opinion heavy. Let me see. As I was telling, Vishwasghatak, I mean, that's very, very regional in Bengali.
But
I loved that. That
yeah,
now is of special importance because I got some time to spend in that same institute. It's a tough question. What books? There's several books that have inspired me.
sure.
I really liked Anandamat. I think I'm giving a lot of Bengali books. Recently, I went back and reread Chader Pahar. It's also
Mm-hmm.
it's for
Beautiful.
kids. So all the
Yeah.
kids or the kids at heart listening, if you get an English copy of the book Chader Pahar, to kind of the adventure in you,
Yeah.
adventurer in you. These are when I was a kid, at times from those times. Nowadays, as I was telling, it's become a little more nonfiction. So the book Species is something that's right now there on the next table that's coming to mind. In terms of some other a book, because books are so personal and the choices change from people to
Yeah.
people.
Sure. And
One
every phase is inspired by something else, and and it's important that you talked about all the Bengali books because that is the maybe the first few books that were
first books we
impacting.
began with.
So
So
yeah,
so while there are many books I really loved, if I have to, the moment you said, "Oh, what's your favorite
yeah,
book?" I think Chadir Pahar came to my mind
yes,
because those are core memories that are hard to
true,
get out of.
true.
Now, there's so many books that I read later, but there's no like one or two books that I
Yeah.
want to strongly
Yeah,
recommend.
yeah. I think everyone who are book lovers, they can start their own book club and list all the books. It will
Right,
be too
right.
many, but at the moment,
Yeah.
just to share.
Another, but another book, and this has a different connotation. It's a comic series called Calvin and Hobbes that used to
Yeah,
come up in the 80s and 90s in
yeah,
newspaper. But much later, this a few of these comics were reminded to me about one of my favorite teachers, one of your favorite teachers too, I would presume, Professor Charuda Kadolkar from
yeah, yeah,
Guwahati. He used to mention about a few of the Calvin and Hobbes. And around the same time, a few of my friends had recommended them to me. Then later, my sister presented an entire set about it. Somebody would think, okay, it's as casual as kids' comics, but it's about a 6-year-old boy with a lot of, deep philosophical insights into the world.
yeah.
And this has been a series that my husband and I used to, at one point, read, like just laugh about it over
Okay.
coffee, a few of them, especially because these are from the 80s and 90s times when we
Yeah,
were growing up, when we were 6 years old. So you could kind of see the connection. And now with another toddler at home, I can see some of the connections. And may sound very trivial, but I think there are some very deep rooted philosophy in those comics as well. So
yeah. I haven't
as a
gone
not
back.
cheap
Thank you for
suggestion,
mentioning. I should go back now and check again.
and see a few and think about it more from an adult perspective that is 6-year old. And
Yeah,
I think there are some very deep philosophies, because I couldn't think of any one book. Like, for example, of course, I love Lord of the Rings and those things, so but there's not one book that I would right now. I'm reading a book by Sanjeev Sanyal about the different rivers of India, but all
mhm,
of these are personal choices. But
yeah,
I think Calvin and Hobbes is something
yeah.
that everybody will have something to learn from.
Thank you for the mentions. I you have already talked about some of the role models, and do you want to mention the role models, peers, or mentors who had shaped your life in a deep
Yeah.
way?
Yeah, definitely. So if I had to mention by names, I mean, again, all my PhD advisors, my postdoc advisors, but special mention to Professor Anthony Arbach, who was also one of my PhD mentors. By the way, he's now, the recent news is he's now, of course, retired. He should have retired much earlier, but he used to love his work. So he worked just a couple of years back. He retired on the same day. He sold off his house, took a camper van, and is now traveling all over USA on his own.
Wow.
So he tells me, if you have to reach me, email me in advance, because I may not see my emails for a long time. But he's the person who's taught me about the big picture and good mentorship. The type of mentorship I want to emulate for my PhD students. My postdoc mentors at Los Alamos, both Professor Nana Karan and Betty Korber, I've learned a whole lot from them. And right now, I think my all my colleagues, I learned so many things from all of them, my students. So all of them are different sources of role modeling for me, people I want to, learn different things from. So actually, but again, the earliest role models were my parents. So that's where I would begin. So it's a bit of everybody that I wish I could kind of become into, a mix of all of these that I want to become into.
And it is not a it's not a solo journey. We get impacted, influenced by so many people, and that's why I asked this question,
So
because
that's a
it
very good
from
question.
outside it feels like a success of one person, but so many people have contributions to it, right?
Right.
Thank you. And if our young listeners or any listeners want to reach out for anything, whether LinkedIn is a good
Yes, LinkedIn
place.
is a good place. Email is a good place. I think LinkedIn is a good place, of course.
Okay,
Yes.
thank you. Thank you. I have the last question. So, what was the most challenging phase of your life, and or the biggest failure?
I see. Yes, yes, yes.
And then, if you want to go back now, your current self goes back to that person, a younger Srirupa, what
Right.
would she advise?
I mean, at each point, whatever little failure is there, at that time, that seems to be the end of the world. 10th grade seemed like, okay, this is thankfully, there were no failures at those points. But of course, at that time, those seemed to be the biggest challenges. And down the line, none of them are big enough. I remember my, Calcutta University, the first Calcutta University exam was not at all close to what I had envisioned to be performing at the level of, and also I wasn't too aware of the grade system of Calcutta University. So that seemed at that time to be a big failure. But at this point, again, looking back, it doesn't seem like it. I think it only had positive impacts as to kind of bringing my focus back into what I should be doing. And Therefore, it again shaped me into what I am. There have been a lot of other challenges, starting a tenure track and at the same time having a baby and writing grants and after getting grants, managing those grants, balancing personal life and academic research has been a challenge that I'm still trying to learn from. But you brought up failures, and something that I learned, and I also always try to remind everybody is, yeah, and this is a series that if you Google, and if anybody who's listening Googles, will often come up that it'll come up that many of the top contributing scientists, inventors, very high achieving people, not just in terms of science, in terms of in general in society, many times different people are given the task of writing a CV of failures. And for all of us, our CV of achievements is much shorter. We could write that in a page or 2 pages, or 3 maximum. But our CV of failures can run into pages. So I think it's always good to write your own CV of failures by the side, to remind yourself where you came from. And at the same time, remember that everybody, even the Nobel laureates, have long CVs of failures. So ultimately, it doesn't matter. It is what you have learned from them. Down the line, many of these failures seem like good stepping stones that led to what you are today. And also, especially in academia, you do research. Many of them fail. PhD takes so many years. Why? Otherwise, if you ask any PhD student at the end of the PhD, how much cumulative time did it take to do the actual work? It may be 1 or 2 years, but there were many other years of learning and failures. Same for job applications, same for award applications, award nominations. At so many attempts that you make to do different things, you have a lot of failures, and then you need to be successful once.
Thanks for these wise words, and thank you for sharing your journey, and hope we had decoded your transitions, interesting transitions, a little bit. And I'm pretty sure your nuggets of wisdom is going to be very important for our listeners, and these are actually they can implement right away. You gave very insightful suggestions. They can be implemented and be worked on right away. So thank you for that.
Thank you, Shandari, for even hosting this. I've followed some of your other work like this, and I've had very interesting time listening to some of your other guests. Thank you for doing it so nicely, and thank you for giving me this platform. It felt very nice sharing my story. I hope if somebody can take something of benefit from here, if nothing, at least the fact that everybody comes with a long trail of failures. Even the biggest, most achieving, and the Nobel laureates are the highest achieving people have. So not to be demoralized by them. But thank you for giving me this platform and hosting this so nicely. And I love the name, you've given up your podcast. It's a beautifully named podcast.
As yes, thank you. And it's a service, hopefully, to the young generations, and it's a work of symbiosis. Basically, you and me together, we can achieve it. So
Yes.
I cannot alone do it. Thank you for your time again, and thank you for. I had a wonderful time. Thank you.
Same here. Thank you. My pleasure.
That was my conversation with Professor Srirupa Chakraborty. A journey across physics, biophysics, industry, national labs, and academia. What I especially found powerful in this episode is how naturally her path shows that scientific identities can evolve. She began as a physicist, but instead of treating her background as a boundary, she used it as a foundation to move into biophysics. We heard how her academic training at Presidency College IIT Guwahati and the University of Buffalo shaped her scientific mindset, and how her later experiences at IBM, Los Alamos National Laboratory, and now Northeastern University helped her to develop a broader view on research, collaboration, impact, and leadership. This conversation also gave us a real look at different research environments: the PhD lab, industry research, national labs, and faculty life. Srirupa spoke about the patent writing, postdoctoral choices, the academic job market in the US, building a research group, and the importance of networking in ways that are genuine and purposeful. For students, PhD researchers, postdocs, or anyone thinking about academic or industry transitions, her story offers both practical guidance and reassurance. You do not need to have every step figured out, but you do need curiosity, openness, discipline, and willingness to keep learning. If you enjoyed this episode, please like, comment, and share it with someone who might find this conversation useful. And don't forget to subscribe to the YouTube channel and follow us on the podcasting platforms so that you don't miss any future episodes of the DPT podcast. As always, you can find the people, places, and topics discussed in the show notes or in the description box below. So until next time, keep exploring, keep questioning, and keep learning.